We are going to be determining which of the following molecules are polar. The molecules are SO3, OF2, BeCl2, and CCl4, and O3 or ozone. Each problem is going to contain 3 steps. You're going to have to draw the Lewis structure, determine the bond dipoles, and determine the net molecular dipoles. We are going to start with SO3. To begin, you will need to draw a Lewis structure for SO3. Begin by determining the total amount of valence electrons. For this molecule, there's a total of 24 valence electrons. Next, place electrons on the outer atoms until each one has a full octet. If there are electrons left over, place those on the central atom. If there are not enough electrons, create double or triple bonds as needed. As you can see, for the SO3 molecule, 1 double bond is needed between sulfur and one of the oxygens. To determine the bond dipoles, you'll need to look up the electronegativities of the atoms. The arrows will point to whichever atoms have the highest electronegativity, and those atoms will have a partial negative charge. Oxygen's electronegativity is 3.0 and sulfur's is 2.5. So all 3 of the oxygens have a partial negative charge and the sulfur has a partial positive charge. Therefore, the dipole arrows will all point to oxygen since they always go from positive to negative. To determine the net molecular dipoles, we need to take a look at the molecular geometry. SO3 has 3 domains that are all the same, so therefore it is trigonoplanar. Each one contains bonding pairs. Since all the domains are the same, the dipoles cancel each other out and the molecule is nonpolar. We're going to repeat the same 3 steps for each molecule. Now that we have the Lewis structure for OF2, we can determine the bond dipoles. F is the most electronegative atom, therefore the arrows will point to the 2 fluorine atoms and they will have the partial negative charge, and oxygen will have the partial positive charge. The molecular geometry for OF2 is bent since there's 2 non-bonding pairs and 2 bonding pairs. Therefore the molecule is polar since all the domains are not the same. After drawing the Lewis structure for BeCl2, we can see that the chlorine is the most electronegative atom and will have the partial negative charges, and Be will have the partial positive charges. We can also see that all domains are the same here, so the molecule is nonpolar. The same goes for CCl4. After drawing the Lewis structure for CCl4, we can see that chlorine is the most electronegative atom and will have the partial negative charges, and carbon will have the partial positive charge. We can also see that all domains are the same here, so the molecule is nonpolar once again. Ozone is slightly different. You must draw the Lewis structure for this atom to determine if it is polar. Since it is made with the same atoms, no bond dipoles can be drawn because they all have the same electronegativity. But to determine the net molecular dipoles, we must look at our Lewis structure. We can see that ozone has 3 domains. One domain consists of a non-bonding pair and the other 2 consist of bonding pairs. Since these domains are different, we can say that the molecule is polar. So out of this group, only 2 of the molecules are polar, OF2 and O3. Common mistakes include drawing the Lewis structure wrong, so I would say always go back and look at your rules and make sure that you're drawing it right, and also always check the electronegativities and make sure you know your geometries, your molecular geometries.